Hey guys, welcome to Coronavirus Earth Science. We're in weather day 4, and today is a big day because we start pressure. And I'm going to be honest with you, if you know and understand all the stuff I go over today with pressure, you should be good with most of weather. So today is a big foundational piece of this entire unit. Just a reminder, grades that I'll be checking on Saturday will be these two things. You got the layers of the atmosphere lab that you should have done yesterday. Again, the video was in the day 3 notes. Take a look. It should have been easy. Just make sure that you follow all the directions in the procedures. And then you have the Google form that I'm putting up for Friday. Okay, all of this stuff, make sure it's done by Friday because I am checking it on Saturday. Okay, so atmospheric pressure, how does it help us predict the weather? So when you look at the weather on the news or whatever, and they say a low pressure system is moving in, what does that mean? Same vice versa with a high pressure system. So that's where we're going today. So a couple review questions. State the following relationship. As the altitude within the troposphere increases, so as you go up in the troposphere, what's going to happen to the amount of water vapor? This is all pertaining to page 14 in your reference table. That's your layers of the atmosphere page. And if you do, you should know that it is, according to this, right, going up in the troposphere, the amount of water is going from here to here, so it is decreasing. Okay, so decrease. Identify the approximate altitude in kilometers of the mesopause. Okay, so here's the mesopause. Here's the altitude. They wanted it in kilometers, so that's going to be 80 kilometers. And then here, identify the list that shows the atmospheric layers in the correct order upward from the Earth's surface. So it's troposphere, stratosphere, mesosphere, thermosphere. So that would be choice 2. All right, so again, this is page 14 in your reference table. Make sure that you know it. These are the 3 things that affect weather. You only experience weather in the troposphere. All that stuff you should know by now. All right, so what is atmospheric pressure? So this is the weight of the air pushing down on you. All right, this is an example of water pressure, right? You go in a submarine, you go underwater, deep, deep, deep to the mid-Atlantic ridge. What's going to happen? All that water pressure is going to crunch in, and that took this styrofoam cup and turned it into this. All right, same thing as when you're going from the top of a mountain climbing down. There's going to be more air on top of you, all right? And that is atmospheric pressure, right? Think of pressure as weight or force. So what is the weight of the atmosphere? Okay, so how does altitude affect pressure? Again, this is something that you can get from page 14. As you go up, there is less pressure. So that's an indirect relationship, right? Indirect, because the line is going down. And that makes sense. As you climb up, there's less and less air on top of you, so it's going to weigh less. All right, here's a big one. How does temperature and moisture affect atmospheric pressure? All right, so let's talk about warm air versus cold air. If you look at cold air, cold, less energy, the molecules are more dense, right? They're closer together. Versus warm air, which is going to be more spread apart, less dense. So, if it is warm, right? If it is warm, look, the molecules are more spread apart. This is going to be low pressure, right? They're not all jam-packed on each other. Whereas if it's cold, they're going to be more on top of each other, so that's going to be more pressure. All right, and then as far as moisture, the way that I like to remember it is I think about sponges. If you look at the low pressure one, this one, there is a whole lot more open space to fit moisture in there. So there will be more moisture. in low pressure. Whereas in high pressure, it's already filled up with all that air, all those air molecules. There is less space for moisture. Okay? So the big takeaways here is, aside from these relationships, these things right here. This is everything. You need to know that. All right? And the way that I like to remember it, all right, is for low pressure, I write low and I underline that W. That low stands for warm and wet. All right? So if you can remember that low pressure is warm and wet, then you can remember that high pressure is the opposite, cool and dry. And then I want you to think about it. If it's cool and dry, would you consider that nice weather or bad weather? If it's wet and it's raining and nasty out, then that's going to be bad weather. So low pressure typically brings bad weather. High pressure typically brings nice weather. This is so important. You have to know it. Okay? All right. So how do we measure it? What is this tool called? That is called a barometer. All right, barometer. And as you already saw on page 13, you can use that in millibars or inches of mercury. And in your reference table, you have that converter that you can use. All right, how atmospheric pressure is measured. Take a look. The more the pressure pushes down on this platform, it's going to push this mercury up. Just like that. Okay? So, here's what it means. If the barometer is falling, that means that it's getting lower. That means low pressure is coming. Low pressure, what we just went over before, means bad weather. It's going to get wet. It's going to get nasty. All right? If the barometer is rising, it's getting higher. That means that you have high pressure coming. High pressure is your nice weather. Okay, big major points that you have to know. If you take away anything today, that's going to be the takeaways. All right. How do we convert? So again, this is your page 13. It's pretty simple. Take a look. If it's just please remember, these are going up by ones. These are going up by 0.01. Okay. So 30.15. If you look, here's 31.5 is right there. That's going to be converted into 1021, right? You come across, you're right here, 1021. Next one, 978. Here's 978 right here. What's that going to be over there? Again, this is 80. This is 0.85. So that's going to be 0.88. So 28.88 inches of mercury. All right, and that's millibars. 1019. Here's 1019. What's that going to be? It comes up to one line before the 10. So that's going to be 30.09. Okay. And then we have 29.73. 29.73 is right there, and that is just about 10:07. Okay, so make sure that you can read this chart. It's pretty simple. Just make sure that you know what they're going up by. All right, millibars goes up by ones, inches goes up by hundredths. All right, summary. Pretty simple. As the temperature of the atmosphere at a given location increases, the air pressure will most likely. All right, so as the temperature gets warmer, what's happening to pressure? Remember, low, warm, and wet. So if it's getting warmer, the pressure is getting lower. Okay? Whereas high pressure, okay, is cool and dry. So on a July afternoon in Florida, the barometric pressure is 29.85 inches and falling. This reading indicates, all right, if it's falling, that means that it is getting lower. If low pressure is coming, that means that bad weather is coming. Okay? Common questions that you can see. 3, a high pressure center is generally characterized by, all right, high pressure, we already said, cool and dry. All right? Pretty simple stuff. So, your job is to finish this worksheet today. All right, so I took you through the notes. We got this page done. I want you to get your this worksheet done. It's pretty simple. It goes hand in hand with the notes. And just something for you to keep your eyes out. Listen, I had this in the content library. That's a good thing to keep track of. This is a great summary page. Summary, just to keep your eyes on. All right, I hope everyone has a great day. Don't forget to get your lab done and the Google form done by Saturday morning. All right, have a good one. Stay safe.